Dennis asks, how long will it take for people to notice an increase in their weight if the Earth's average radius expands by 1 centimeter every second, assuming the average composition of rocks remains the same? Let's imagine that the entire Earth, from the crust to the core, begins to expand uniformly beneath our human structures, which do not increase. To avoid a scenario where the ocean is depleted, let's assume the ocean is also expanding. When the Earth begins to expand, you will feel a slight jolt, and then you will rise at a speed of 1 centimeter per second without feeling any constant acceleration. You will not notice any significant changes for the rest of the day. After the first day, the Earth will expand by 864 meters. Gravity will noticeably increase only after a long time. If you weighed 70 kilograms at the start of the expansion, by the end of the first day, your weight will be 70.01 kilograms. How quickly will our roads and bridges begin to crumble if the Earth expands beneath them? Not as fast as you might think. Here's a puzzle I once heard. Imagine that you have tightly wrapped the Earth with a rope that touches the surface all around. Now imagine you want to lift the rope 1 meter above the ground. How much additional length will you need to add to the rope? Millions? Hundreds of miles? The answer is about 6 meters. The circumference is proportional to the radius. So if you increase the radius by 1 unit, the circumference increases by 2 pi units. After 1 day, the Earth's circumference, equal to 40,000 kilometers, will increase by 2 pi multiplied by 864 meters, or by 5.4 kilometers, which is approximately 0.01%. This can be easily endured by almost all structures. Concrete contracts and expands over significantly greater distances every day. One of the first real effects you will notice is that GPS satellites will stop working correctly. The satellites will remain in roughly the same orbits, but the incredibly precise synchronization between ground stations and satellites will be disrupted for several hours. Most other clocks will function normally. However, if you have very precise pendulum clocks, you might notice something strange. By the end of the day, they will be 3 seconds ahead of where they should be. After a month, the Earth will expand by 26 kilometers, an increase of 0.4%. The surface gravity will increase by only 0.4%, while the Earth's mass will increase by 1.2%. Surface gravity is proportional to radius because as the planet grows, its mass increases, but you also move away from the center. You wouldn't notice this weight change even on the scales. The mass of the human body varies much more than 0.4% over a day, let alone a month. Gravity itself varies by the same amount between different cities. What you will notice is the expansion. You will see many cracks opening in long concrete structures and the destruction of elevated roads and old bridges. Most buildings will likely remain intact, although those firmly anchored at the base may start to behave unpredictably. In a year, gravity will increase by 5%, and the surface understructures will expand by 5%. You will likely notice an increase in weight and will certainly feel issues with roads, bridges, power lines, satellites, and underwater cables. Your pendulum clock will be 5 days slow. In 5 years, the force of gravity will increase by 25%. If you weighed 70 kilograms at the beginning of the expansion, now your weight will be 88 kilograms. Most of our infrastructure will collapse. The cause will be the expansion of the Earth by 25%, not an increase in gravity. Surprisingly, most skyscrapers can withstand significantly higher gravity. The limiting factor is not weight, but shifts like wind or Earth expansion. In 10 years, gravity will increase by 50%. Let's assume that the atmosphere is also expanding. Otherwise, there wouldn't be enough air to cover the growing Earth, and it would become too thin for breathing. As the atmosphere expands, the air pressure at the surface will increase due to both the greater gravitational force and the larger volume of air. But we will be able to hold on for a while longer. In 40 years, the gravitational force at the Earth's surface will triple. At this moment, even the strongest people will move with great effort. Breathing in such a dense atmosphere will be a true challenge. Trees will break, and crops will not withstand their own weight. In 100 years, we will experience more than 6 units of gravity. We will not be able to move in search of food, and our hearts will not be able to pump blood to our brains. Only small insects and marine organisms will be able to move. Moreover, at this stage, ordinary air will become toxic due to high oxygen content. Perhaps people will be able to survive under controlled pressures while lying down, managed by robots. But this will be almost the limit of what we can achieve. Will Earth ultimately become a black hole? It is difficult to answer this question because Dennis's premise is that the radius is constantly expanding while the density remains unchanged. For a black hole to form, the density must increase. According to realistic physics, by adding mass to the Earth, we will eventually exceed the strength of the chemical bonds that can withstand the growing internal stresses, and the Earth will begin to contract rather than expand, turning into something like a dimly glowing white dwarf star supported by electron degeneracy pressure. After about 1,500 years of expansion, if the mass of the Earth continues to increase according to the original assumption, it will exceed the Chandrasekhar limit for white dwarfs and become a black hole. But before this happens, sadly, people will not be able to survive more than 300 years, because at that moment something truly amazing will occur. As the Earth grows, the Moon, like all our satellites, will gradually spiral closer to it. In a few centuries, the Moon will approach Earth so closely that the tidal forces between them will exceed the gravitational forces holding it together. When the satellite crosses the boundary known as the Roche limit, it will begin to gradually break apart, and for a brief time, rings will appear around Earth. Let's take a look.